Chapter 24, Holiday and Resonant, Problem 6. When an electron moves from A to B, or B to A, along an electric field line, the electric field does 3.94 times 10 to the minus 19 joule of work on it. What are the electric potential difference VB, VA, VC, VA, and VC, VB? Okay, for A, we want to start with V equals minus work over Q, which equals potential, that's U, potential over Q. And we just want to solve for V. In this case, it's just going to be V equals minus the work, which is 3.94 times 10 to the minus 19 joules, divided by Q, which is 1.602 times 10 to the minus 19. And this is going to equal this 2.45 volts. And we can put a minus there. It's just a difference. So an electron has a charge of minus. The positron would have a charge of plus. So this answer should be plus 2.45 volts. All right, let's discuss this a little bit. Let's say work, which we know is equal to force times a distance, dot a distance. And in this case, we know that work is also going to equal Q V B minus V A. The dot product means that it's the cosine. So work is the cosine distance times the force, the cosine of theta. So the cosine of this path is equal, we could look at it as 0. So the cosine of 0 is equal to 1. So the shortest, it acts B to A, just straight. So any path, you can take any path, but only the components that are parallel with this electric field line will be indicated by this cosine function. So part B, it says VC to minus VA, C to A. If we went straight from C to A. It's the same as if we brought this C over here along this equipotential surface, and no work is done on the equipotential surface because this is at a 90-degree angle. If we bring it over to here, and the cosine of 90 degrees is equal 0. So no work is done. So B or C, we take C here to A, we get the same answer that we got for part A. B, so that's going to be 2.45 volts. This is a conservative, so it's path independent. You may as well take the easiest path you can find. Now part C, VC to VB. Okay, VC to VB, we just said that's 0 because 90 degrees of the electric field line. So along the equipotential surface, even though this is an imaginary surface, it's still, that will give you 0. So part C equals 0.